All right. So we don't really need a million guesses. I can hear myself. Let's fix that. Okay. I think we should be good. Let me also set up the YouTube here. Let's load this for now. Keep saying this. I really need to rewrite the blurb. For now as well. Yeah. I seem to get more spam in my chat on YouTube specifically than the Adafruit account does. I don't know exactly how or why. All right, here we go. Okay, so quick introduction. Hello to everyone who is watching. My name is Tim. Go by foamyguy on GitHub and Discord. Discord is where you can join the chat, which is visible on the screen there. The Adafruit Discord, adafru.it. And then this chat is the live broadcast chat, but there's also CircuitPython development and a bunch of help with channels and a bunch of other community channels that you can join and hang out with folks. So head there if you're interested in that. What we will be working on is CircuitPython. Specifically, I will be picking up where I left off last night on the deep dive with this async example project on the PyPortal. Just realized I didn't have the camera set up, so let's get that. The PyPortal, which is one of the types of microcontrollers that CircuitPython works on, is very blurry. Let's focus it a little bit. Means I shuffle all these windows again. This one on top, so that's all right. Let me do that. Focus it. There we go. All right, so this is a PyPortal. On the back, there is a main chip right here, which is basically a tiny computer. You can think of it the same as like the computer in your cell phone or a tablet or something like that. In this case, there's also a secondary chip over here, which is facilitating the Wi-Fi connection. They talk back and forth. And this one also obviously has a nice big screen on the front of it there. We are writing Python code that runs on this little device. Specifically, what I'm looking at today is like async Python code and interacting with widgets on the touchscreen. This screen rather has a touch overlay, so we can have like buttons and switches, and we're going to work on a slider today. So that is the specific stuff I'm interested in today. If you're brand new and you don't know really what I'm talking about, this is a good place to start, circuitpython.org. And also I would encourage you to head over to the Discord. There's lots of great resources around for folks that are new and want to get involved. This page has some other pictures of microcontrollers, so we can also go to this page, downloads, and see more. You can see that they come in all different shapes and sizes. Some of them do have screens, like the PyPortal, the one I'm using, has a screen on it. Some of them have like an e-ink screen instead. Some of them have a tiny screen. Some of them have no screen at all. All different form factors, shapes, and sizes of these different boards. And we're writing the Python code that runs on this board and interfaces with outside hardware. CircuitPython is an open source project. Anybody can contribute to it, but the primary financial backing comes from this company right here, Adafruit. This is their website, adafruit.com. They sell some of the microcontrollers. They sell some of the extra peripherals that you can plug in, such as this thing I have plugged in right here is a magnetometer. This is an Adafruit board, a little breakout device with a sensor on it. They have all sorts of different sensors, pretty much any kind of sensor that you could imagine. They probably have a breakout and a hookup that allows you to communicate with the CircuitPython microcontroller. So this is another way you can help support the project is by purchasing your hardware from them. So you can do that at adafruit.com. And definitely those of us that work on the project and get paid by them to work on the project definitely do appreciate if you will purchase hardware from them. Trying to cement the async IO concepts into the gray matter, yeah. Yeah, that's awesome. I'm glad to hear it's helping. And to be honest, yeah, that's kind of the same thing I am working on with the stream. So I figured we might as well broadcast it and learn together. So let me get device workspace. And so folks, I imagine most people watching this probably also saw the deep dive yesterday. I'm gonna have to probably go put up the sun blocker in a few minutes. But if you didn't catch that and you're interested in like what this project that I'm working on is more specifically, I would encourage you to go back and find that deep dive. This is where I made sort of the first half of this, and I'm continuing where I left off. I haven't done anything in the interim, so it should follow through pretty well if you watch that deep dive video, and that one's on YouTube under the Adafruit account. Let me scooch the microphone just a little bit. Let's make sure it's not in frame. Okay. Oh, just barely. Actually, it's starting to come in frame. There we go. And so right now you can see it's actually broken. It's printing an error. I think I probably did not remove all the things related to the light sensor, which is one of the last things that I worked on. Oh, okay. So actually this is CodePy for the macro pad. I also have plugged in, but I'm going to unplug actually. I had it plugged in to run the timestamper yesterday, and then I totally forgot to do timestamps. It took us a minute to get up and running, and after that I was a little scrambled and never did go back and do any timestamps. Let's refresh this. Get our CodePy. So this is actually the Pi portal now. So I had two devices connected. That's why I had a CircuitPy and a CircuitPy 1. The Pi portal was CircuitPy 1, but I unplugged it and then reset everything, and now it's CircuitPy by itself without the number. So this is our code. I'm guessing I probably just left light sensor in somewhere. Or, yeah, here it is. Okay. So let's actually put it back. I think what I'll do is, what I described at the end of the stream yesterday is let's get the value from the light sensor and let's draw it on the screen. That way we do introduce a third sensor, but then we'll do something else for the brightness. We'll do the slider, I think. Talked about yesterday using brightness based off the light sensor. So we need to find back to the initialization. And I don't think, will this have history? I don't think it. History? Whoops. Have history from yesterday? Yeah, maybe. Oh, no. This is history from the macro pad to the Pi portal, which is not really what I want. This is from yesterday, but it doesn't have stuff I'm looking for. Okay, we'll just put it back. We had the initialization for the, oh, maybe this one. Initialization for the light sensor. Oh, this one's got mag sensor. It's kind of weird how it's like copying it. It's like comparing it to other programs entirely because it thinks they were the same. They were actually different. It looks like we're not going to find it in history. That's all right though. We'll just grab. I think where we got it from yesterday was CircuitPython Essentials for analog. Actually not a lot to it. The light sensor presents itself just as an analog input, like you would read a potentiometer, something like that. So you don't really have to like have a specific driver for it. You can just read it as an IOpen. Okay, we still have get voltage actually. So we can just append the value. Let's take this down to scale 2. And then we'll just work the light sensor value into our string. To start with though, let's get it fixed back to running. So we'll go here, light sensor, maybe that I think should get us back. Yeah. Okay, we have room now. Let's add in the value from the light sensor. That I think we're just gonna go to one of these. New line. Okay. So where we call this from, we need to pass app state. I think I might change the name of app state. In the original async IO examples, this was essentially referred to as state, although I don't think it's an application state. Really what we're holding are all of the interface things though in this script, rather than the state of like what, you know, whether a button is pressed or isn't pressed or anything else like that. We're holding the actual UI controls, the interface controls. I almost think it might be better to rename this to I'm gonna say just interface, but I don't know. Does that graphical interface maybe? What gives me pause is interface also has a separate meaning in programming. Like if you implement an interface, you're like agreeing to implement certain methods. I don't know if Python has interfaces like that though exactly. Where do we create it inside a main? It would be interface. This way the thing we're passing around actually is descriptive of what's on it. In this case is all of our widgets, like our label, our switches. We'll add the slider to it later. So really nothing else should change. As long as I didn't break anything, this should still just work the same. And we also have our voltage now as well. And we are getting a much higher value today. Yesterday we were 0.0456-ish. Today we're up to all the way 0.28. And it's just because of the sunlight, I assume. We're getting more natural sunlight. So let's move this label, I think. Why don't we stick it kind of as far as we can to the top left corner? And that'll leave us room below to make a slider. We should also put units, I guess. This is volts. I think this is volts at least. I just refreshed this page as if it was like a JavaScript page that I wanted to run again. But I had already saved before, and that was the real thing that did the refresh. Somebody mentioned the decimals on the temperature, and I definitely don't like the way that it's like jumping back and forth when it drops down to only 1 decimal. Why don't we specifically cut that off at 1? I think we do by... Let's see. 0.1f or something like this. Nope, sure not. That's interesting. I guess it's because we must have crashed inside the task again or whatever. Yeah. So this is definitely wrong. Is it F? D? I don't know. How do we format decimals? Python string format decimal places. I've done this before. I just don't remember the exact way. Ah, it was so close. Colon. 0 colon, and then I guess we would want .1f instead of .2f. No? Can't switch from automatic field numbering to manual. Maybe we don't need the 0. Maybe we just need .1 colon? Or no colon, I guess? No? Key error. Light sensor. Key error. So it works if we take that out. So that's definitely the problem. Why don't we make another line? Let's separate this further so we can kind of see more clearly which part's broken and which part's not. Okay. Row 1, 2. Maybe colon 0.1 with no 0. So if the 0 is like trying to be an index. There we go. That's what we want. And we could probably do a similar thing. Why don't we cut the voltage to maybe like 3 decimals? And I think it would look better if these were indented, or maybe we could give them labels to the left. I don't know, that's not that big a deal. Let's go ahead and move that label though to the top right. So right now we are placing it with anchor point and anchor position, but we have 0, 0. Let's do 1.0 and 0. And then this will be display.width minus maybe like 8 or something like that. Let's just bring it in a little bit. Just try like that. Yep, that's much what I wanted. It's still fairly far from the top, actually. I was thinking we would go closer. I was thinking we would go closer to the top. Interesting. guess that's just the default line height combined with the fact that we're scaling it. Feels like we're awfully far away from the top for being 0, 0, but the top of the label is actually up there. There's a little bit of space between the top of the glyph and the top of that label, depending on which glyph it is. I think there might be some glyphs that could go all the way up. Not for sure, though. So magnetometer changes values when we move it around because it's sensing the Earth's magnetic field. Temperature sensor is on the back. This thing. It's basically like a chip. If I touch it, then it... Right now it's going down because my skin temp happens to be colder than what it was. Take my finger off of it, and it'll go back up. And then our light sensor now, if we block it out, we can get it down to 0.07, which is actually still higher. That's like higher than what we were getting last night when we unblocked it. So we're like a full... We're like totally outside the scale we had yesterday. No worries. Not a problem. Measures 1100. 10 to 50 for brightness range. Nice. Okay, so measure lux maybe instead of voltage. Gives you a little bit of a wider range. No need to apologize, though. It seems like an interesting concept to me, and I still think it'll be an interesting thing to do. I just didn't want to in this particular project. So, let's see. We found yesterday Jose made a slider. I have not ever checked it out before. Is the one? Yeah. So this looks pretty cool to me. I don't recall seeing it when it came. Looks like Jose did it almost a year ago. Straightforward. Well, I guess the initialization seems pretty straightforward. We, of course, will need to grab the library. It's on PyPy, but we could also get it here. If this is in the community bundle, or any bundle, we could install it with Circuit, maybe. I don't know if it is, actually. I'd be interested, though, in moving this into CircuitPython.org. Pull request. Minute. Improve docs and stuff. Types on some of the doc strings. X. One seems like an interesting change. That one seems more functional. A lot of this stuff look like doc stuff, but this one, like it would be more functional. We might keep an eye. If we get weird behavior, we might come back to this PR that wasn't merged yet, and maybe we need the code from it. Let's grab here. Display brightness also contributes. Oh, really? Yeah, I hadn't thought about that. I guess that makes sense, though. I mean, phones are like that for sure. Some of the super nice, like, high-end Samsung phones or LG phones, it can have a crazy bright screen, but if you leave it all the way up, turn into a little hand warmer, basically. And I'd never really thought about that with the PyPortal, though. It does make sense. Oh, this is not even... Let's go here. Oh. And it's just slider, so this would be from slider import slider. Got a crash. Let's going back to the wrong PyCharm. Keyword argument max size. Okay, so that is just an old, that's a thing that got removed from group. So we will, why don't we get the Python version of this? Why don't I clone this for now? We'll get the Python version and we will need to tweak some stuff inside of it. So it'll tell us the line. We could just search for it, I guess, too, but 177. 77. So groups no longer have a max size. We don't have to do that anymore. You can just keep adding more things to a group. Eventually you'll run out of RAM, but there's no hard limit before you run out of RAM. I don't think. Certainly not one you have to declare, I guess, if nothing else. You used to have to say, like, I want to make a group and I want to have slots for this many items. But now you can just say, I want to make a group, and you can add the items you want. So we did not crash, which is good. We don't have a slider, but that's because I didn't actually add it to the group. Slider, let's call this brightness slider. And then let's go add those, I guess, right here. Main group append slider. Okay, so it's on there, but it's definitely not where we want it. And then we also need to put the code that will check for touches and move it accordingly. And then of course we'll need to check the value and actually do something with it as well. But start with, let's just move it to a more spot. So let's say, can we give this like a width and a height also? Let's see here. Yeah, we should be able to. And height. But let's make it wider as well. We have some more room. We don't actually need it to be that small. Width. Let's see what like 100 looks like. Well, we'll leave height. We can leave height alone. Let's just go further down. So screen is like 240. We have 3 of those switches. I don't know, maybe like 180. Oops, that was X. 80Y. That's what we wanted. There we go. Okay. We can go wider still. Let's go wider. Well, did that actually change even? It does, okay. We might as well go like full screen pretty much, except for the padding. So let's say width is going to be display.width minus padding number, which is 10 times 2, because there's padding on both sides. Margin, I guess it's more. Yeah. Okay. So now we need the code to handle it. So that will go inside handle touch events. If there is a touch event, then I guess we probably just need to send it to slider. There will be like a contains or a selected type. When inside, and then when selected. Interesting. I might choose slightly different names for these, I think. Oh, that's not background, that's brightness. Yeah, like this I think could just be contains the same way the switch and the button are. If it functions the same, it's possible I misunderstand how it functions too. Then when selected, it says brightness. When selected. Press this also. It's pretty slick. It goes past the right edge just a little bit. Feels like, to me at least. We should maybe have a little bit more margin, actually, because the edge of the screen kind of throws it off a little bit, too. I also didn't do, like, any real calibration on the touchscreen. We probably could get the touch behaving better if we did, like, an actual calibration. I just copied the default values. Let's go smaller, though. I think we have 10 margin right now. Let's make it... Let's go more like 30 and see how that is. This will be 30. This will be 30. Now we got more space on the outside of it. Yeah, it does definitely go past the edge there. Oh, I even got all the way outside. You can also just click. I was dragging before, but you can also just touch where you want. Okay. So now there should be like a value or something where we can get the current value. Okay. Round rec, so this is using display shapes. Value. Oh, value is true. Should be a number. Maybe just the doc string is wrong. Let's see what it's actually set to. So if we go... that, what do we actually get printed? Okay. So that does... I don't know when it would be true. Doesn't seem to be true. That might just be left over, though, honestly. This feels like it was taken maybe from the Switch and then left over a little bit. Maybe they're just... Jose never finished making this widget. So maybe we can tweak it a little bit, though. position. Widget was touched. Manages internal logic. Widget is selected. So when we touch it, it's going to end up calling this, which is going to look up the location that got touched. And then set the switch handle's X coordinate based on the touch X. And then call selected is control thing? I'm not sure. Where does selected come from? Yeah, it is control. Okay. And it also returns. Oh, okay. This is returning the new X. Interesting. I think we should be able to access it with something like this, though. And value, I don't know. We don't really have a switch anymore that I am aware of. Stroke. Yeah. I think maybe this, some of it's just left over. It may have gotten started from copying in fact, these switches that we're using here. These ones up here. That's my guess. Okay, so we definitely have a little bit of work if we do want to move it to CircuitPython.org and publish it, put it in the CircuitPython.org bundle and such. We would want to do a couple of things. Probably remove the references to switch, but also I think change value. So value, we could just change here. Value, this is going to return a number. What do we want to do? We want to range from 0.0 and 1.0, or do we want to range like 0 to 100? Or do we want like 0 to 65,000 or whatever? What range does analog in give? Okay, I think we should match this. We should basically treat the slider like an analog pin. Zero to 65,535, which is a power of 2 minus 1 or something. Certain number of bits to make that number. 16 bits maybe, or 8 bits, I don't actually know. So we're going to return an int, current switch value, current slider value, int. And to start with, let's just do switch handle dot x, and we'll do a mapping from this, but let's see what it's printing first. You know, for now, why don't we add it to this even? Just Back on another new line. Whoa, not like that though. I don't know, we don't know the units. Well, the units are pixels, I guess, but that's not really what we're going to end up with. String slider brightness slider dot value. This will be another thing passed to here. I wonder if we should just pass interface into here and then access all these things from interface. I guess we talked a little bit yesterday about multiple arguments versus a single one that holds multiple things. Okay, right. I'm down. Brightness slider. Wait, what did I do here? Did I overwrite? Yeah. This is what I need. And then when we call this, we will now pass another one of these. Oh. Graphical interface. Oh wait, no. Oh, no. I was totally wrong. These are not graphical. These are the sensors. The label is the graphical interface. The switches don't actually go on this thing. And the rest of the stuff are the sensors. Yeah, this was a bad name. We go back to application state, or do we come up with a better name? It holds sensors and it's holding the label. I don't know. Let's just take it back to application state now and keep thinking about it. See if we come up with a better name. Application state. And then where we make it application state. Again, though, this is one of the really nice things about PyCharm is it's super easy. Like, change your mind on a variable name, you can change it, no problem. You don't really have to do too much work. So, where did we call? Here we'll need to hold the slider on the application state as well, I think. It's kind of weird that our switches aren't on the state object. Those feel sort of weirdly outside the async IO portion of the code, kind of. They're not part of the state object, which is weird. Self.slider brightness slider. Whoa. Get passed in here along with the application state. So maybe, yeah, maybe it would make more sense if those were on the application state. I'm not sure state is the best name for it, the way that I'm using it. It's not really representing state. It's holding all of the various components that are being used, both graphical components on the screen as well as physical hardware components connected to the circuit. Maybe we should be having two different ones. Maybe one of them should be holding all the physical things, and one of them should be holding all the graphical things. So here's one place where this was still... Oh, we ran out of room. I'll put it to scale 1 for now, but we'll go back to scale 2 because eventually we're not going to show this as a number. You know, the other thing we could maybe do, get away with this without doing the scale, is line spacing 0. Yeah, much tighter, but actually see everything now. Maybe even go a little bit more. I think 1.25 or something is default. Objects are sensors, some are physical, some are on screen. That's true. Yeah, that's true. Maybe a good way to break it up would be one object holds all things that are inputs and one object holds all things that are outputs. In our case, the main output is the label, although we're going to add in the screen brightness, so maybe we'd put the display onto the outputs, and then inputs would be the 3 switches, the slider, and all the sensors. Objects, output objects. Okay, cool. Yeah, so now we get this moving. Looks like we can't quite get back to 1, or I mean back to 0. Oh, I did manage to get back to 0. I was going to say I thought it was because once we get... I think basically the problem we're having is once we get too far to the left, then we no longer count as contains, or whatever it was called, when inside. Once we get too far to the left, we no longer count as when inside, which then means we no longer call when selected, which means we no longer update the thing anymore. Ultimately, we would probably want a different test here. Instead of when inside, it should be like when you first touch down, then we want to know whether or not you're inside the control. But then every subsequent frame after that, we no longer necessarily want to know that you stayed inside. Really what we want to know is that you haven't lifted back up yet. You're still holding down. And while you're still holding down, you should be allowed to move your touch point outside of the control, and it should keep registering events. So if you move it all the way outside the slider to the left, it will bring the handle all the way back to the left. And since I have not lifted up yet, it would still be counting these as touches, and therefore still be moving that further to the left. And then once you lift up, then the control stops looking at the touches and reacting to them. I don't think I'll make that full refactor right now, but conceptually I think that's probably how this type of widget should work. We are getting a value though, and our value is roughly going from 0 to, I guess, $59,260, which is that 320 minus 60? Yeah. So we're going from 0 to the width of the bar. But realistically, we should actually be stopping further back. We should really be stopping at the width of the slider minus the width of the handle. I would say also, if I were like really doing a deep dive on this widget, looking for ways to enhance it, the other thing I would do is map the touch point to the center of the handle. Right now, the touch point is basically anchored onto the left of the handle. So the handle is always just a little bit further to the right than the touch point. But if we anchored that touch point in the center, then the handle would be right on where the touch point is at. Let's see here. How's it going, Hams Labs? Nice, thank you. Well, people will hang out a bit and see what new things I can pick up from foamyguy while doing some minor CAD things. Nice, yeah, CAD's a lot of fun. I like OpenSCAD is the one I have the most experience with. It's a really interesting, different kind of building, basically. Building physical shapes instead of virtual programs is a different thing for me, but it's a fascinating exercise for sure. And a 3D printer, being able to like design a shape and then print it is a super interesting and rewarding experience for sure. Oops. Well, YouTube, I am still here. So yeah, I think there's a couple of things we could do if we want to ultimately make this widget a little bit nicer. So maybe we'll do that on a future stream or a future deep dive. That sounds like a pretty good project, like trying to shore this up, fix a couple of the bugs, get it up to date, like remove the max size and all that stuff, and then tweak the way it works to be centered and change the edge over here and give it a value, that sort of stuff. And then once we have that, we could put it in CircuitPython.org, I think. Maybe ping Jose, see if he's interested in helping us work on it over there. I don't know, Jose hasn't been quite as active lately. I'm guessing they just got busier with other stuff going on. So we want to limit this, though. How do we get the actual limit into this? So right now, does it clamp it right now? Because it knows not to run off the left edge. So this is getting the touch point, and then just setting the X. So in fact, right here, this is where we could do the centering thing. So instead of set the X of the handle to the touch X, we would set the X of the handle to the touch X minus 1/2 of the width of the handle. 1/2. What is this thing though? Switch handle. This is a round rec. Yeah, that should have a width, I guess. If not, I guess we could use knob width. Does this actually have a width? It does. Okay, so honestly, I think that should anchor it to the middle of the touch point. like anchor the handle to the middle of the touch point. Ooh, no, totally broke it. How did that break it? Okay, why is this yellow? Expected int got round rect. Oh. Yeah, can't divide a round rect by 2. Turns out. So honestly, I feel anchored closer to it, but still feels like we're on the left though. Would we not need to divide this? Recalibrate the touchscreen? This got us pretty much to the center. That is weird though. It should be half, I think. So yeah, maybe we should recalibrate. Where's the calibration example? C Grover? Did you make a touchscreen calibration recently? This is Linux, which is not what we want. Like all Arduino anyway. We could always... We don't necessarily need a fancy calibrate script. We could just use simple test and then record the numbers that are highest and lowest. So I want to go back to touchscreen actually. What I'll do is this for now. Whoa. So this is a tuple with 3 things. X, Y, and then I think pressure maybe? How hard you're pushing? I'm not sure on the last one though. So we'll do... So if it's -1, then we want to do this. Or if min x is greater than the current x. Is p0. Ah. Yeah, this is what I was thinking of, I think. Let me keep this just in case if this ends up not being what we want. We can switch back to that. I think this is exactly the same concept, but finished out a lot more with a nice interface. So basically we're touching all around, trying to get it to hit the minimum and maximum of all the edges. I don't know if there's like a exact right path to take or something, but I think as long as we get all the edges, we should be pretty good. You can tell it's getting pretty solid on that little square. So let's see, is this printing as well? Indeed it is. So now these numbers are what we put in up here. Way up here at this point. I'm gonna save this. Thank you for linking that, and I mean for writing it as well, obviously, but for linking it here so I could use it. Code touch calibration. Fine. Okay, and we definitely don't need this part because that did exactly what we wanted. Okay. Yeah, because now it feels like we're on the right edge. I think our calibration is what was making that feel weird. So we do want to go back to divide by 2 on this. Yeah. There we go. I mean, it's still not, pixel perfect, but I don't think we're ever going to get pixel perfect out of resistive touchscreens either. And it's way better than it was for sure. Do we still go outside the edge? We do, but not as far, which makes sense if our anchor point is further back. Oh, and we managed to get out the left edge as well now, actually. Okay, so I think we want to... We want to clamp this to... staying inside the slider, so... Let's think about this. So X is technically still right anchor based, or left anchor based, I should say. So we're going to need to stop at... We're going to need to basically not let this go negative. New lock X. X between that and 0. So if it's less than 0, then it will take the 0 instead. But we also want to clamp it on the other side. So I think we also go new lock X equals min new lock X. And then this would be switch handle dot width over 2. No. No. Yeah, I think we don't. And in fact, we don't divide. Instead, what we want to do is we want to get the full width of the slider and then subtract the width of the handle. So we actually need self.width minus. So if the full width minus the size of the handle is bigger than, no, is less than the value we're trying to move to, then we'll pick it instead. But if the value we're trying to move to is less than the full width minus the width of the handle, then we stay with whatever our new value was. Path not important. All screens are different, even along the edge. It's nice. Yeah. Perfect. Okay. So now we don't go outside the edge anymore on either side. 240 is our maximum because we did the full display width, which is 320. We have 30 pixels on either side that are not valid. That gets us down to 260. And then our handle must be 20 pixels wide. My math checks out. Knob height? Knob width, rather? Oh, interesting. It's related to the width. Okay, so height over 2. Yeah, height is 40. 40 over 2 is 20. 20 is what we had. Okay. I would maybe also, if we do end up refactoring this and improving it some, moving over to the org, I think we could make these separate so that you're able to just specify the knob size, or I would call it the handle size, I think, separately from the size of the slider. But it's totally fine right now. So now we know that our range is from 0 to the width of the slider minus the width of the handle. So we can then map that range to 0 to 65, 535, 65, 635, whatever the vex, 65, 535. And to do that, I think we use simple IO. I think there's like a map range or some kind of function that does this. Map range. X in min in max out min out max. So now inside a value, what we're going to do is, instead of just returning the handle by itself, we're going to return simple IO map range, the value. So then it's in minimum, in maximum. So that's 0 and self dot width minus self dot switch handle dot width. Those are our in minimum and maximum, and then out minimum is 0, out maximum is 65535. Oh, interesting. This turned to a float. Nice. I guess map range by default returns a float. We don't necessarily need to show the float number. Can just round it off to an int. It doesn't really matter either, honestly. We could just leave it alone and that would be totally fine as well. Yeah, that's looking pretty good. It would be nice if the slider widget library mimicked the UI of this physical slider. Oh, sometimes I get this. Sometimes when I go to a link, it takes me to a login page. Third time's the charm. There we go. What, how does this one work? Let's see. What do we get with this? So it's I2C. What does it send back to us? Looks like 1024 maybe. Well, 1023, which is also a different value of a different power of 2, but -1 since we start on 0. Same as 65535, just a smaller power. Does anybody have one of these? Seagrover, do you have one of these? Have you ever used it before? Do you know if it's 1024? That's kind of what I'm interpreting from this code, at least, or this comment, I should say. Oh, okay. It's not like its own custom I2C thing. It's actually a seesaw with an analog in. Don't have one. I bet you we just look in seesaw. Oh. Whoa, 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 whoa. We can do 1024 as well. I think the difference might just be that Seesaw probably does 1024 to save some amount of RAM or something. It's a really tiny... Seesaw basically is a microcontroller itself, but it's running an even smaller type of code. It's not CircuitPython code running on it. Arduino code, I guess, or C or something. And it is like a microcontroller Swiss Army knife IO extra thing. Gives you a bunch of extra pins, and you can treat them as digital or analog or connect other stuff to it. And then it communicates back to the main one with I2C. My guess is that this probably uses 1024 instead of 65535. Oh. No, so this does say here 5535. Now I wonder. Scale the potentiometer values 0 to 1023 to the color wheel values 0 to 255. So this is creating an analog input. I think this is probably a pin number. A pin number on the seesaw. Put this in the same browser. When we init, we do have the pin number, yeah. And then this is passing the value into here that it's getting from here. Might be a bug in the line guide code. Yeah, it would still work. It would just give you less. It would give you fewer colors, would it? I think it wouldn't let you use the whole. Wouldn't let you use the whole color wheel, only the first part of it. Let's see if the says anything more about it in here. ATtiny 817 is the microcontroller on this one. Bunch of different address jumpers, so you can basically use different addresses. If you have multiples of these seesaws, you can choose different address for each one. Looks like you have a whole big old binary table here too. Looks like there's, what, 16 different addresses? So you could use a lot of these things together. Doesn't say much about the value. See if Arduino code looks any different. I mean, obviously it looks different, but if the number, if it looks like it's using the same number or not. This one looks like it's getting 0 to 255. But this would depend on the Arduino library analog read. It shows here it goes higher than 255 though. It was also printing here. And in fact, this one is up to 570. Interesting and mysterious. Let's ask. Uh, I guess it's also possible. Well, no, Seesaw. And if the Seesaw library says 0 to 65535, could the slider be somehow hooked up to only use part of that range? Experience with or have the device. Test. Okay. How's it going, NearDoc? Actually, I think it would go through the color wheel multiple times. Well, I guess because color wheel is assuming 0 to 255, so if you're feeding up to 1024 through it, then it wraps around. I guess 4 times-ish. But if you were feeding up to 65535, then it would wrap around a bunch of extra times as well. However many that divided by 255 is. Highlights and overarching issues of raw values versus CircuitPython library values. For example, analog inputs are actually 12 bits represented as 16 bits shifted. Oh, interesting. I didn't know that. The max value can only reach 65540. Max value can only reach 65540, not 65535, but 65540 is bigger, isn't it? But it goes, does it go higher than 65535 sometimes? Or maybe CircuitPython's analog I/O scales values to the 65535 range, meaning the lower bits will all be 0 if the precision is less than 16 bits. Six five five two zero. Okay. minus 15. CP color wheel modulo is 256. Okay. I'll wait and see if anybody who has that slider... Am I logged in? No. I logged in over here. Have I bought one of these? I don't think I have this thing. Let me check though. And sometimes I have... No, I'm not logged in. Logged in here. There are times where I've thrown some extra things into an order that I didn't have a specific need for. So occasionally I'll be logged in and I'll be like, oh, I bought one of these? Because that's one of the nice things about the Adafruit site. It will tell you, like, hey, you bought this on such and such a date. And so that's a good way to know whether I have something or not sometimes. I don't remember for sure, but I'm not logged in. And I would have to two-factor. I guess I can do it real quick. Shouldn't take that long. Let me do it real quick. Here. Okay. Application code. Almost there. This is slider trinky also. JP uses 1024. So I wonder if Seesaw docs are wrong. Because it does... Whoa. It's cool. It was all white, or... Yeah. Huh. I don't recall seeing this thing before. There it is, slider. No. Yeah, somewhere at the top here, I think it's like right in here. It would say the date that I bought it. Got some in stock though, I could throw it in the cart. Let's see if this page says anything. No. Uses in this project. Is this the controller? Is that this thing? Or is that a different one? This looks like a JP thing, yeah. Let me put the chat back here. Seesaw mentioned 65535. Philosophically, I'd prefer the value to both be normalized to 0 and 1.0. Yeah, I could see that as well. I think that would be a fine solution. I don't really have a strong opinion on it one way or another, as long as it's just clearly published somewhere what it will be, especially because simple IO always makes it so easy to map. But, you know, it is extra boilerplate code. Like, if you want to write code that assumes 0 to 1, you could add the extra map range to it, but then that just becomes a thing you have to keep copying over and over. If everything was equalized in the drivers, then you could treat it the same always and never worry about mapping it. Is this the same project you were talking about? JP's Workshop 10.12.2 Neo Slider Controller? Code the Neo Controller. Yeah, this must be it. Yeah, this one's actually mapping it from the 1024 down to the 128. It must be, I think it must be returning 1024, and then I guess that either the seesaw docs here are wrong, and this actually goes 0 to 1024, or somehow that slider doesn't use the full range available to the actual pin. The pin is able to go higher voltage than the slider is allowing it to get to, or lower voltage, or because it's resistance and not voltage or whatever. But basically maybe the seesaw library is right, and this can go 65535, but the hardware implementation inside of this, the circuit might not, it might be clamped to only the beginning of that range, 0 to 1024. And then that would cause it to only give you 0 to 1024 when you're using this slider bar, even though it's technically just doing a seesaw analog read, which can go higher if the circuit allows it to. Yeah, totally agreed. I do think it would be good to be the same across libraries, but I also think there's some cases where it might, like, I could see the seesaw having a lower value, a lower max value than analog in the core, for instance. And I could see that being a limitation on the microcontroller that the seesaw is made of. If it doesn't have enough RAM to store values as large as what we have available to the core, then scaling them down makes sense in order to give you still a range that's usable for something. But definitely in the ideal world, they would all be the exact same. So if it's 1024, then it would be that everywhere. And if it's 65535, then it would be that everywhere. Or if it's 0 to 1, then it would be that everywhere. That would be ideal. foamyguy, I think you're going to have to test it. CircuitPython, we'd want the value to be 0 to 65535. The left justify DAC values, which I think this is what you all were talking about in the chat here. So using that code doesn't have to worry if they're 8, 12, 10 bits. But I don't see the code that actually does this in Seesaw. So I'm thinking more and more, I'm thinking that Seesaw is, that everything is probably technically right here, and that maybe this slider just needs documentation that says 1024. Oh, you found a different doc that says 1024. Where did you see that? The inline doc. We're in here. Log input. Oh, I see. In the C firmware that runs on the Seesaw. Okay. I think I have a Seesaw or some Seesaw-based devices. Like Crickets, I think, have a Seesaw on it. I think I have a Cricket. I might have a plain Seesaw by itself. So I think it's between one of two things. Either the Seesaw docs here at the Python layer are incorrect, and this should actually just be 1024. Or this is correct, but somehow the hardware involved in this slider doesn't allow it to use the rest of that range, and instead clamps it electrically with the hardware involved, the resistances on that actual pot slider, clamp it to 0 to 1024. I think either of those could be the case right now. Just checked Seesaw, and it has 12-bit ADCs. Yeah, I'm pretty sure I have a Seesaw that looks like this. Oh, that's probably killed the chat too, didn't it? I gotta remember, if I click links in the chat, it opens in the same browser window, which I assume kills, either hides the chat altogether or shows the other page instead of the chat. I haven't actually looked at OBS when I do it. I thought I had one of these. I don't see it listed here. Maybe I could have got it from Micro Center too. That's the other thing, is Micro Center is one of my favorite places to hit up, and I'll buy Adafruit stuff from there, and then of course it won't show on the page. I think there is a new Seesaw too, though, right? But I do believe the one I have is this one. But I think there's a newer one with the Sema. Yeah. And I think this also uses the Seesaw library still, though. It just has firmware that makes it behave the same as the other one. Yeah. This is one of the screenshots that I generated from that tool we created a little while back. Yeah. This is interesting, though. This is C code from the Seesaw that you linked here does make it seem like 1024 definitely. I don't know. For now, let's do it. We'll do it 1024 because it seems like from the slider projects, that's what it's doing. And we'll just keep in mind at some point if we can get someone to test it on a Seesaw and see if it does ever actually return 65535, or if not, then maybe just the docs are wrong there. And it sounds like if those are 12-bit ADCs, I guess there should be more room, but maybe there's some other limitation somewhere that's clamping them to smaller range. Got the AT Tiny one. Where did we do our map? I guess, oh, I did it inside of the slider here. Yeah, so let's go 1023, be inclusive on the right side. Yeah. Okay. Now, back in our app code, when we read well, let's see, where would we do it? I think we just do it here, actually. Wrong code. So let's go display brightness equals, I'm actually going to use map range again. So min in 0 and 23 are the in, and then outs are I want to now go 0.1 low side, 1.0 high side. And then I guess the other thing is our slider starts at the left, but our brightness actually starts at the most bright. So maybe we should either make the slider start to the right, or we should start the brightness lower. Yeah. It's pretty nice looking. I will say it doesn't come through the camera quite as well. And you can kind of tell the purpleness of the slider bar gets way brighter. Maybe this would be a spot where this would help us. Yeah, a little bit. Makes it easier to tell it's getting dark. I think I want a different color for the slider bar instead of the purple. I just want a gray, since it's not changing the color of anything. Can we preset the widget slider? I don't know. Let's find out. Doesn't look like it. We could make a property setter, though. And just kind of go backwards with this, so I think we just take the same logic as this stuff, but instead of touchX, this is new value. Is that right? Yeah, I think so. And that would clamp it. If you gave it less than 0, you would end up getting clamped by max, and if you gave it more than... Oh, no. We need to we still need to map range it. We still need to map range it. New value goes in, which is 0 to 1024. So in is 0 to, well, 1023. And then out is actually what we did here. These two. We go from 0 to 1024 down to 0 to width minus size of the handle. And then maybe we would not actually need this min-max, I'm not sure, but I'm going to leave it for now just in case. And then I guess if we wanted it to work from the initializer, we would also need... We should do it that way, maybe. So does that crash? The seesaw breakout, it goes from 0 to 1023. And Dexter got the same results. How's it going, Tammy? Happy Saturday. Thank you. So maybe just seesaw. Seesaw docks. Here probably should just be 1024. If anybody wants to PR, that'd be awesome. Otherwise, I'll keep it in mind and eventually wrap back around to it. We did crash. No attribute switch handle. So does it initialize the switch handle after? Yeah. Create slider. We probably need to do this after we create the slider. Okay, so that still works correctly. Here to 1023. All right. So we should be able to set value now when we create the slider, or we could set it after we create the slider. We'll test both, make sure both work. Where did we actually make the slider? Value equals, let's just try, well, let's go max, 1023. So then this should start on full brightness. Although, will it, maybe it won't trigger the first time. Oh, can't convert float to int. Right, map range returns a float. Oh, interesting. So for one thing, the brightness didn't change with it, but that's because we manually put the brightness down and we're not changing it in the rest of our code unless the slider got touched. Since the brightness is inside of here, the slider's not been touched, then it won't adjust. So that makes sense. What doesn't make sense, though, is we ended up with 980 instead of 1023. Oh. Right, so I guess the other thing we actually need to do in here is Well, no, nothing is really accessing self._ value. Yeah, self._ value is all the way gone now. Basically, we don't have a value variable. We're always deriving value from the x of the handle. Why would we end up with 980 though? I did do 1023, right? Value 1023. That function. Okay. Mapped to 40. Does sound like max. Are min and maxes breaking it somehow? Yeah. I don't know why that is exactly, but I think we don't actually need to do the min-max. Yeah. Now we're on 1023. We're full brightness. You can go down from there to go dimmer. Back up to full. All right. I'm liking that. How's it going, Keith? I think slider should implement or override contains and selected. I agree, Dexter. I think that's true. Instead of when inside, I think it's called, and when inside and when selected, I think this one should be contains, and then when selected, maybe possibly just be selected, or forget what all is on control. Yeah. Yeah, either it should use this one, or I think it should be maybe renamed to like when touched, maybe just touched, like it is being touched right now. We're actively managing touch events for this widget. I do agree with that. Map range does the min-max for you. Okay. Yeah, it was weird though. I would have thought the logic would be the same. And so I would have thought that the max min wouldn't have changed anything. The weird part is that it ended up making it smaller. But I wonder, am I off by 10 here? But I can't be off by 10 here because we're able to drag it all the way to 1023. It's not like we stop at 980 or whatever it was. You can definitely drag it past that and get all the way to 1023. I don't know. Don't know. But removing it is definitely the easiest solution, since we don't need it at all anyway. Different than Arduino map range? Yeah, but I'm doing the map, I'm doing the same CircuitPython map range essentially here, and then also essentially here. Oh, well, no, I'm not. This one's not a map range, but the same min-max, I guess. I don't know. I'm mostly confused why it was broken one place and not the other place. I probably did something different in the place that was broken, though, versus the place that's not. There's probably some difference I'm not accounting for. Let's see. Can we change the purple? What are this? So we have fill color, outline color, background color. So fill color, I guess this is probably our purple. Let's go slider fill color. I think I just want a gray. So we have the white bar in the middle. I think let's just go for like, we want it to be brighter, I think, than the handle. The handle should stay darker than the background, so... Oh, do you think fill color or background? Fill color or background color is the purple. Okay, background is white. This should maybe be called stripe color as well. I don't know, background and fill, those sort of feel like they're describing the same thing to me, at least in terms of the actual terms used, but in reality, fill is more like what I would think of as the background, but it's the outer stripes, top and bottom. And then it looks like that the one called background is actually for the stripe in the middle. So I would go, I think, stripe color and then either make this one background color or maybe keep fill color. But definitely making this one stripe. As far as an actual color, though, I think I want maybe something like, how does that look? Oh. Oh, that changed the handle. Okay, hold on. Okay, hold on. Yeah, so everything I said about the names doesn't really apply all the way, because I actually didn't realize what was what. So fill color is the handle, so I would actually say that could be called handle color. Where did the purple come from? Do we not have control over the purple? Yeah. This is the purple, isn't it? Yeah. And that's a little bit too bright to go with the white. But honestly, before I just keep changing it here, why don't we make it one of these? So yeah, let's actually go ahead and rename some of these. So fill color, let's make it handle color. Handle color. And then background color, let's make it stripe color. Stripe color. And then let's make... So this makes it backwards, like it breaks backwards compatibility, but it's alright, I think. Fill color. I'd rather these be hexes, truthfully, but... It had 990099. What is that in tuples? 060. Okay. I feel like our purple got darker. Hmm. Interesting. Is there a different conversion? I think this will actually still work, even though we called it a tuple in the type. Most of the code that accepts colors actually accepts either. Yeah, that's brighter. So the... The range is not the same with GIMP as it is with CircuitPython. Interesting. Case, slot, and knob. I like handle better than knob, I think. Knob implies that it turns to me. I think it's referred to as knob a couple of times, like in the code here. If I were changing everything over, I would probably change all the... If I actually understand what knob means in the code. My assumption is that knob is referring to the handle, the gray small part that we can actually drag. Although handle, I do grant, makes it sound also bigger, I guess, or something than it really is. I don't know. But knob, to me, knob makes me think it turns when it doesn't necessarily. Although it is a slide pot, so turning is like part of its sort of parent object's existence. So it makes sense also to still kind of refer to it that way. Case and slot. I do kind of like slot, I think, for stripe. Case. Probably get behind case as well for fill. I don't like those. I'm not going to necessarily change them right now, but I do like those. If we do make a larger kind of like refactor and put this into CircuitPython org, I will probably go with slot instead of stripe. And maybe case instead of fill. Case instead of fill is also nice, actually, because then it's not... The backwards compatibility is not as damaging. Like with this called fill color, it actually functions totally different. If you had code initializing it before and you switched to this version, it would function different. Whereas if we call this case color, it's still not backwards compatible, because if you had code that passed in fill color, now we don't have a fill color. But at least it's not like changing the color of something different that you weren't expecting. Oh, there's an issue already? Oh, well, there's not an issue already. There is an issue now. What is this? If I use matrix reset, do I have to check if event pressed again, or can I use it inside of here like so? Let's do if event pressed. Event key number in held. Send. I'm asleep trying to implement press and hold. I don't know what matrix reset does. Yeah, I don't have like any idea. I don't think what matrix. I didn't even know I had a reset function. I guess I don't know what that would reset. Just the pin states, but the pins. I mean, the pin states are tied to the real world. If you call reset in code and it tries to reset the state, but the pin is still pressed, I don't know. That feels weird to me. But again, I don't know what reset's supposed to do. I could be misinterpreting what it's supposed to do. Knob is commonly used. Okay. I will say, like, the fact that it is already used, in spite of it not being the term that I lean towards, if it is already used, it does make sense, right? Like, whatever I think in my brain doesn't, like, if the general public has already sort of decided, or the people who sell the widgets have already decided on the name, then my feeling about it is definitely less important. So yeah, this definitely does persuade me a little bit further back towards calling it knob. Thanks for sharing and checking into this. Whatever names we end up with, let me see, scoot it in a little farther. Should include an image of a slider widget with labels pointing to, yeah, definitely, totally agreed. I think there is maybe a picture. Did I skip past it? Did I imagine that? But yes, we absolutely should. Especially if we're going to rename them, we should absolutely include them. It does. Well, it has two here, but they were labeled differently though, right? Because some parts of the code referred to this as knob, some parts referred to it as handle, and then slider, I changed it to stripe. Did it used to be slider? Maybe that one was. No, it used to be one of these three, fill, outline, or background, so it has the diagram, but it wasn't quite matching the names. This thing, though, these are an easy type of diagram to make. There's actually, if anybody's interested in making custom widgets, there is a thing in displayio layout, annotation, I want to say. And actually, maybe is there one? We should see if it's in CircuitPython.org, actually. I should stop pointing people to here. Instead, always try to go here first. I think it's called annotation. Yeah. Annotation makes these like pointer label thingies. So this is a super useful widget if you do want to make a custom widget and then also make a diagram, photo, like documentation picture like this. You can use the annotation widget to add those labels and point them to the different places. And this is inside CircuitPython.org already. Displayio annotation is the name of that library. Added a task to read the seesaw analog input. Nice. Async IO. One of the things I want to experiment with is, we talked about it a little bit yesterday. I don't think I'm going to do it today, but I would like to experiment with making the slider itself, or not slider, sorry, the buttons, these switch round. Yeah, switch round is what the widget's called. But to make these switches use async IO as well, so that the values can keep updating when the switch is animating. Right now, there's like a split second while the switch is animating that the actual values here don't update because that switch animation is actually blocking. But we could, I think, make switch round. And somebody, you see Grover maybe, or Dexter, one of you two, I think yesterday mentioned to make the selected function basically inside of the switch. This one. have like an async version. So we'd have like maybe selected async or something. And then we might also need internally to the switch, we might also need like a animate async or something. I suspect selected is calling an animate, which is actually what's blocking. But if we made async versions of those two, then I think our code here could utilize them, and our other tasks would be able to run during the animation. I think that'll be a fun thing to experiment with as well. Yeah, purple. So I'm still in getting the purple. So we added the new. I'm probably gonna head out after this too. Sometimes I go a little bit longer, up to about 3 hours. I don't know. I probably will end up changing around my Saturday stream schedule a little bit. I don't know exactly where I'll land. Next week, I think I'll still plan for the same time. But eventually, I may move it around, or it may become more likely that I do shorter times. You know, closer to 2 hours than 3 hours. But usually, I mean, honestly, I don't really plan an exact time. I just kind of go until I feel like stopping and doing something else. Just kind of just how I do it. I think, so we should be able to pass now, what did I call it end up being? Fill color. Be able to pass fill color. Get paused again? Yep. I feel like I didn't have as long that time, YouTube. Could slow down the animation to make the pausing clear. We'll need to spend a few days to explore the async stuff. It seems to be useful for UI things. Yeah, totally agree. Now that I've started playing with this stuff, Keith I think I'm in agreement with you. Like, it gives us an ability to write code that will ultimately turn out, I think, easier to understand and maintain. You'll have to understand the async stuff, so that in and of itself makes it a little bit harder to understand. If you do understand the async stuff, though, it allows you to separate the different tasks in a way that I think ultimately will make the code easier to understand, because it will keep smaller chunks together instead of having one massive main loop that is basically a state machine checking different states and doing different things based on other stuff. You can separate all of those into smaller chunks and only worry about each one individually and not worry about putting them all together. Let the async IO stuff do that for you. Color. So I think, what does 9s look like? Oops. Wrong window. There we go. I think darker still. I will say this looks better to the naked eye than it does to the camera. Full brightness is kind of just washed out on the camera altogether, but I do think we could go for just a touch darker still. Lucky 7s. Yeah, that looks pretty good to me. Yeah, I like that. All right, this is awesome. I will ultimately probably push this to the async IO library as another example. I guess it's kind of specific to this sensor I have, but I mean, the code is fairly straightforward. You could pretty easily just do your own I2C sensor, whatever it may be, whether it's magnetometer or something else. And then really the only adjustment you would need to do is, like, if it's not a magnetometer, then you would want to change the logic here that's pulling the value from it and putting it into the string. It also would be good probably to change the name of it to not be mag sensor, but that's probably optional. and then you'd be good to go. So even though this does use a specific one, I think I may include it. Maybe what I'll do is add like a high-level Boolean or something that's like use external sensor, and then if that's true, then it will do this stuff. That way you can use it without that sensor and still get the core of the example. But I do want to include it because lots of folks, I think, will want to know or want to be able to copy an example of this thing right here, pulling data from a sensor, formatting it, putting it onto the screen, keeping it updating live with the latest values from the sensor, along with managing all the touch inputs and everything for the GUI. I like the idea of including an example that does the external one, even though it makes it a little bit more difficult to share the example, because not everybody might have the exact same external stuff. Oh yeah, async with Wi-Fi is going to be amazing. Being able to make a request in one of these coroutines would be super duper cool, because then you can still keep a nice responsive UI while a request is taking place. Right now, a request is fully blocking, so if you make the request, then like this is going to stop updating. We wouldn't be able to slide the slider. We wouldn't be able to touch the buttons. All that stuff would be kind of paused. But if once we get async requests, then the request can go in just another coroutine and all this stuff can share time. That will definitely be amazing. Nice. Timmy, looking like aiming for Wednesdays and Sundays. Wednesday evening and Sunday morning. I will say I like the idea of Sunday morning, or mornings on the weekend in general. I think I mentioned this yesterday, but one of the motivations for choosing Saturday morning for me was I knew we had folks in Europe that like to watch Deep Dive, and I knew Deep Dive was super late for them. If they actually stay up and watch it, it's like really, really late, depending on where they're at in Europe. So I chose the morning on Saturday to give those folks a chance to be able to watch something at a better time in their local time zone. But also, I just like getting up on Saturday and working on stuff like this, so it worked out pretty well for me as well. That was kind of long-winded, but I look forward to Sunday mornings. If you end up doing Sunday mornings or whatever schedule you end up with, I'm just happy there are more folks streaming this type of content. So thank you, Tammy, for being interested and for getting involved on Twitch and doing the streams and stuff. I think it's really cool. Yeah, I will say that's a good point, Seagrover. Especially when it comes to network stuff too. Network stuff, like lots of things can go wrong with the network, and so debugging. We've even seen a couple examples while I've been working on this where like one of my coroutines crashes and the other ones don't, and then the debugging gets kind of weird since the whole thing doesn't crash. I will say that's a really good point. Like once the async requests bring a lot of upsides, but they also do bring added complexity for debugging. That's definitely true. Gonna have more flexibility in the schedule once you start the new job, because then my workday will be aligned with Eastern. I may adjust some things. Nice. Yeah, congrats on the new job as well. I think you shared that the other day, maybe during the meeting or something. So, congrats on that. That's really cool. And again, I'll reiterate again, thank you for streaming. I think it's awesome. You get more and more folks streaming this type of content. I know there's like all sorts of different programmers on Twitch. I watch a fair amount of the programmers on Twitch. Sometimes people working on games. Sometimes people working on like just Twitch bot interactive type stuff. There's a couple of folks that do Arduino that I've found that do some pretty cool stuff with like actual circuits and things like we're doing here. But not that many. And I haven't run into any other CircuitPython ones except Tammy. So I'm super excited to see more and more folks diving into that. Of course, other than Scott as well. Scott started a while ago doing the deep dives. But like in the Twitch world, if you go look through, I think it's like software and game dev or whatever, the category on Twitch, you don't find a whole lot of microcontroller stuff usually. But one of these days you will. Nice. Yeah, I will. CircuitPython 2, like, so I can reveal a little bit. The company I work for is a really, really small company. We had like the most developers we've had at once is like 3.5-ish. We had one who had some development skills, but didn't usually get tasked with development tasks. So I count that one as a half. Like he had the skills, but didn't really use them too much. But like 3.5 is the maximum number of developers that I have worked with at my job, and none of them were embedded developers. So none of them were people working on microcontrollers like this. CircuitPython allowed us, like literally allowed us to even have a possibility of making some custom hardware that we could interface with our primary product, which is digital signage. Without CircuitPython, like none of us would have had the expertise. Even with Arduino, like maybe we could have struggled through it with Arduino if we had enough time, but it would have taken so much longer, and I'm not even confident we could have made it there all the way. CircuitPython allowed us not only to like iterate super quickly and test our idea, but then actually implement the custom hardware that the microcontroller plugs into, which we just straight up like would not have been able to do. Like we're basically web and mobile developers, not embedded developers. But CircuitPython allowed us to actually do it. Let me show, since I'm talking about that, I thought about actually grabbing a couple of these and showing them when I was on Deep Dive. I didn't actually end up doing it. Let me run and grab this thing. I think it's an interesting thing to show. I don't know that I've ever actually shown it on the stream or anything, but I'll show you one of the things that we were able to make due to CircuitPython being so cool. Okay. Job is data engineering for a marketing tech company. Nice. Move this out of the way. We may have to zoom out a little bit. No, I guess we can fit it in there. So this was like the more advanced one. We actually had one that was simpler than this that did some other stuff. This one is made for, as the nicely labeled silkscreen could tell you, a lighting controller. So you put 20, I think it's 12 or 24 volts goes in this thing. There's a itsy bitsy plugged in. This gets plugged into the Android device via USB, and then our Android device can send signals, like commands basically, to the itsy bitsy, and the itsy bitsy will flip the rest of these. There's basically like a relay on all of these different outputs, and so each output has a the 24 volts, or it's either 12 or 24. I'm not 100% sure. But it's like a standard. Those are two pretty standard lighting voltages. If you see lighting inside of like a retail store, inside of the shelves and stuff, usually it's going to be 12 or 24 volts. So that's what this works with. And it goes in. It can come out individually, all of these, and the itsy bitsy can turn on and off for each one of them. And it also does PWM out, so it can fade up and down the 12 or 24 volts coming out of all of these. So it's not actually a relay, I guess it's a something else. Transistor? I don't know the right term, but it's able to PWM the 24 volts between 0 and 24 to brighten and lessen the lights that come out. And then there's also 3.5mm jacks, one for each one of the light outputs, that can send a signal back in. So the 3.5mm jack, you can put like basically a switch, a fancy momentary switch that's wired to a 3.5mm, can plug in here, and then that signal can go into the itsy bitsy and ultimately out and back into the Android. And so the Android can like take the signals coming in from those switches, and then the Android can also send the commands back to fade the lights up and down. And yeah, this definitely is a Oshpark. I don't know, do they put no, they don't put an extra stamp or anything, but yeah, this totally was an Oshpark purple. Yeah, This design, I will say, I didn't make the board. I don't really have the skill set to be able to lay out the board. This was one of the partners that I worked with, one of the other developers, who is unfortunately no longer works at the same company. Our company ended up splitting into kind of two different things, and then one of them ended up getting acquired by a different, larger organization. That's where he ended up. I ended up on the side that's like doing specifically our main software. This was the name of the company, CTI Solutions, and we developed a signage software. And then now, like, that signage software is its own company separate, and that's where I work for. And then CTI Solutions went on and ultimately got acquired by another technology company. But yeah, he made this design, and it's super cool. It's got, 12 or 10? 10 of these outputs, and you can drive an LED strip from each one of them. And the Android can control all of them, fade them all up and down. So we had a bunch of nice like animations where it would fade different lights up and down to make a light show or whatever. And then it would also do a thing where like when you trip the switch, it was actually a pull thing. So like you would pick up the product off of the shelf, and that's what fed into the switch. Is when you picked it up, it would close the circuit for the switch, and then it could light up that segment of the shelf, like where you picked up the thing would light up, and then all the rest of them would fade down, so it would like accentuate the one you picked up. This was a really fun project. We don't do a whole lot of custom hardware integration stuff like this. This is the most advanced one we did, but like I was saying before, like we literally just would not have been able to do this without CircuitPython, I don't think, right? Like none of us had the ability to write the code that does all of this any other way. Maybe Arduino, but it would have taken us a lot longer. CircuitPython allowed us to put this together like on a timetable that actually made sense for the project. I think you're right, FETs. Yeah, I remember. I think MOSFETs. I will say like I come from the programming world and am getting into the electrical components world, so I don't quite know all the right terms and everything. I do think, now that you say FETs though, I do remember the person who made it, I think, calling them MOSFETs, talking about MOSFETs. So I think that might be what those are. Yeah. I'll try to find the other one too. I have a smaller one it's basically, the smaller one is pretty much just 4 of the inputs and no lighting. So just 4 inputs, and it sends the signal into the microcontroller, which then forwards it onto the Android, and it can react by playing different content onto a screen. This one's definitely the cooler one though. Every now and then I'll bust this out, and I have a couple of the strips. I don't have very many. I think I have like 2 or 3 of the strips. But it's fun to set it up and play with the fading up and down. Yeah, thank you. Andrew is the person who did this. They haven't been active in the CircuitPython community too much lately, but they were at one point in time. They're probably still on the Discord, but I don't know his name. But Andrew is the name of the person who made it. But anyway, my knowledge is patchy when it comes to hardware. I took an introductory electronics course in high school, but I have a ton of gaps in my fundamental knowledge, and I'm slowly working my way through the art of electronics to fill those gaps. Nice. Yeah, I should probably work through a book like that. I have no formal electronics training. All of my electronic stuff, like I played with electronic kits as a kid. My parents got me some like starter kits and stuff. With the little like springs that you push the spring over and stick the wire in, and then let the spring bounce back, and then that completes your circuit. I had some of those, and I learned a little bit of the basics, but no formal training. All of my formal training is software stuff, and it mostly was just learning Java in high school. I took more classes in college, but by the time I started taking programming classes in college, I really knew most of the languages that those classes were teaching. I was taking them for the credits and not as much for gathering the knowledge at that point. Gaps in math knowledge. Yeah, math is an interesting one for me. I've always found math like fairly straightforward, but I have never committed to memory a lot of what I've learned about math. A lot of times I can approach a problem and be like, I think there is a mathematical solution to this, And if I knew the right words, I could probably search and find it, but I don't just know it off the top of my head. But sometimes I can get close enough just tinkering around with the numbers to stumble upon to the answer, but using art of the electronics as well. Nice. To remember what you learned in college. Ended up focusing on signals, so the electronics part of my degree has been forgotten. Gotcha, yeah. CircuitPython has been my push to learn more about hardware. Again, nice. Yeah. It's a fascinating world. It's a super fun world. Like, being able to write code and turn a light on and off, it sounds so simple, and it is so simple once you've been in this world for a long period of time, but like, coming from having just written programs for computers and being able to all of a sudden like write a program and turn a light on and off or move a servo back and forth, like that's such a amazing experience. For me, it was, at least. Taking that programming knowledge and moving it into the real physical world is super fun and fascinating. I think I am gonna probably head out though. So I got the slider and the brightness put in. I'm pretty happy with the example we have now. Eventually, I think I started saying this before, eventually I'll share it in the async.io library. But I think we will need to do some updates on the slider first, because I have my sort of modified slider that I've been using here. So I think the order of events here will be like, do the rest of the work inside the slider, publish that inside the CircuitPython org, and then we could put an example into async.io examples that uses that slider from where it's in the org bundle. That way everybody will be able to easily get the slider, and I don't have to try to like share my one little customized version of it. Yeah. Thrill of blinking lights never goes away. Totally agree. Probably would have switched from communication arts to computer science or EE double major in college if I'd stayed. General nonsense plus the aftermath of being a victim, we now call a hate crime, derailed my college degree. That's unfortunate. Sorry to hear that happened to you, Tammy. Coming together. Guys, this is an awesome demo to make use of async.io. Makes sense. Explains why you want to use it. Thanks for streaming. Yeah, for sure. For sure. All right, so folks, thank you for watching. I will be back. So definitely I'll be back Friday afternoon for deep dive, Friday evening, and that's at 4 p.m. Central, which is my time. It's at 2 p.m. Pacific, which is how it's been advertised most for deep dive. So I'll be back then. And then next Saturday, I'll plan on the same time, so 10 a.m. Central on Saturday, same time I started today. That was about 2.5 hours ago, so whatever time zone you're in, whatever time it was 2.5 hours ago, next Saturday I'll start up a similar stream. I might be around Monday. I mean, I'll be working on Monday CircuitPython stuff. If I'm working on something that seems interesting to stream, I may pop it on. If you want to get notified of that, I would say the best thing to do is follow me on Twitch, because you'll get a notification if I do start up the stream on Monday. But otherwise, I'll see you all next Friday for sure. And yeah, thanks for watching. Hope everybody has a good weekend.